11 o'clock, so I will get started. Like I said, we're going to do 9.1 today, which there's only 6 problems, but the last couple of problems are pretty involved. So what this 9.1 is covering is what's called the composition of function. So what we did on Friday is we added function. They usually gave us an f of x and a g of x, and then had us do certain things to it. A lot of times we added them together. Can y'all hear? I see what you're saying, Carmen. Can y'all, the rest of y'all hear me? Oh, thank you, Bailey. Press the join audio at the bottom left. Oh, I can see it. It says y'all are connecting to audio now. So it should be working. Okay, so like I said, on Friday, you were given, oh good, 2 functions, and you either added them together, subtracted them, multiplied them, or put one over the other, and then found the domain of what that answer was. Okay, we're going to be doing the same kind of thing here today, but we're going to be doing what's called the composition of 2 functions. Okay, so it's still going to give us 2 functions, like on number 1, the f of x is x minus 1. G of x is x squared minus 5. And it wants me to find what is called f of g of negative 2. Okay, now I will tell you this, Math Lab does a real roundabout way of explaining this. Okay, so I'm going to simplify it for you. The very first thing, this right here, last class, this was like a plus or a minus or a times. That open circle means we're going to compose the 2 things. That says f of g of negative 2. So the first thing you're going to do is find whatever is in this position. Okay? Sometimes it'll say f of g, sometimes it'll say g of f. However they want to do it is how it's going to be done. Okay? Doesn't matter which order it is. Whatever is in this inside position is what you are going to find first. Okay? So I am finding g of negative 2. Now, we've done this several times. What does this mean to do? This means go to your g function, and wherever you see an x, replace it with this negative 2. So that's what I'm going to do. I'm going to go to my g, which is this one over here. Instead of x, I'm going to write negative 2. So I have negative 2 squared, then bring down that minus 5. Then I'll do that math. So let's see, negative 2 squared gives me positive 4, right? Because if you multiply negative 2 times itself, you get positive 4. Bring down that minus 5. And then do the 4 minus 5 to get negative 1. So that's half the problem. Now what you're going to do is whatever this outside is, which in this case is f, you are going to find f of whatever your last answer was. What did I get in my first, the answer I got was negative 1. So that's what I'm going to find f of. So again, I found g of negative 2. When I plugged in negative 2 and did the math, it gave me negative 1. That's what tells me what to plug in to the second part. So now, just like always, what does this mean to do? Go to my f function, which is this one right here. And what do I put in place of its x? Negative 1. So there's my x right off the bat, right? Instead of writing an x, I write negative 1. Bring down the minus 1, and then do that math. So negative 1 minus 1 gives me negative That's your final answer. Right? Number 2, same kind of problem. It's just going to give me 2 different functions. G of f, oh wait, let me write functions up there first. F of x is 3x plus 4. G of x is x squared minus 2x minus 5. And I'm finding G of f of 7. So remember, the last one said f of g. This one says g of f. They can put it however they want. The steps are the same though. What am I finding first? The inside, which this time it's f that I go to first, right? I'm finding f of 7. Which means to do what? Go to your f function. Here's my f. And every time I see an x, I'm going to put in a 7. So I have 3 times, put in the 7 there for the x, plus 4. And then do the math. 3 times 7 gives me 21, plus 4 gives me 25. So all that is that. Now I'm done with the f part. That g just comes down. And what do you find g of? Whatever your last answer was. What was the answer to the first part? 25. So that's what you're finding now is g of 25. Which tells me to do what now? Go to my g function, and every time I see an x, I see more than one x, but every time I see it, I'm going to put in the 25 in its spot. So let's see, the first thing I have is an x, so I'll put in 25 squared minus 2, there's another x, so I'll put in the 25, and then the minus 5. So again, I just went up to G and put 25s in both of those X spots. And then do the math. So the first thing I need to do is figure out what 25 squared is. That means 25 times 25, which gives me 625. Minus 2 times 25, so minus 50. Bring down this, minus 5. And then do that subtracting across. 625 minus 50 gives me 575. Minus 5, which gives me 570. All right, number 3, same exact kind of problem. And then it starts to get interesting. F of x is 3x plus 2. G of x is x to the third. And I'm finding f of g of negative 4. Same steps. Find whatever's in the inside position first. So I'm finding G of -4. Which means go to G. Wherever you see an X, you're going to put a -4. So I see an X right here. So I'm going to replace it with -4. And then it says to cube that. Raise it to the third power. So let's see, what does that mean? -4 to the third means -4 times -4 times -4, which is -64. And then whatever letter is down on the outside, you bring it down, which is F in this case. So now I'm finding F of whatever my last answer was, which is -64. So I go to my F and replace its X with -64. So I'll have 3 times, replace its X with -64 plus 2. What is that? -64 times 3 gives me -192. Bring down the +2 and then add that together, which gives you -190. All right, number 4. This is where it gets a little more intense. F of X is X plus 25. G of X is X minus 25. Now, if you'll notice on this one, it wants us to find it both ways. It wants us to find F of G of X, and then it wants us to find G of F of X. And then below it, you will see, that once you've done that, it's going to want you to find the domain of your answers. So let's do first things first, which is what? F of G of X. Now, remember, math is always about finding the pattern. So that way you can use that pattern that you've gotten accustomed to and use it to solve new and different problems. It's the same kind of problem. I can use the same pattern that I've been using. So what is the first thing I'm supposed to do here is find the inside, right? What's the inside, which in this case is G of X. So this time, it's just not a number. It's an X, which kind of means go to your G and replace the X with X, which means nothing changes, right? But, or I can just say, well, it's asking me what G of X is. And right here, it just tells me what G of X is. G of X is X minus 25. So that's what G of X is, X minus 25. I can't do anything to simplify that, right? I can't put these terms together. One's an X and one isn't, so they don't combine. So that's as far as I can take that part. So I'm done with that part. What's the pattern say to do next? Bring down this F. And what are you finding F of? Your last answer. What's your last answer? X minus 25. Which means to do what? Go to your F. Wherever you see an X, what are you going to put in its spot? X minus 25. So I'm going to F. There's my X. What do I put instead of that X? I put all this. X minus 25. All All right, now I've replaced this, so what do I just need to bring down? That plus 25. And I can simplify that a little bit, right? What happens to that? Then it just go away. I got negative 25 plus 25. If I put that together, it's 0. It's nothing. So these just cancel each other, and I'm just left with x. Now, I'm going to go ahead, even though the next part of the problem says to reverse this and find g of f of x, it's going to ask me to find the domain of both situations. So I'm going to go ahead while I'm on this part and find its domain. Here's the rule on domain. You need to look in 2 spots for restrictions, because that's what we're doing when we're finding the domain, right? Is actually trying to find what x could not be. And then once you find what it can't be, then it can just be everything else but that. So the only thing that we have come across that's given us restrictions when we're talking about domain is if we have an x in the denominator of a fraction, right? Remember, we had several problems, not this, but like if you had, that would have given me a restriction, right? I would have had to say x plus 7 can't equal 0, which would tell me that what x could not equal. Okay, so that's what we're looking for, is the restriction that would look like that. And you look in 2 spots. You look in your final answer, of course. But you also have to look in this part, because you wouldn't be able to get past that part if there was something there that made it undefined. So what I'm looking for is any restrictions in these 2 areas, which means you're really just saying, okay, in either one of these spots, is there a denominator that has an x in it? There's not even any denominators, right? So that means the domain can be anything. I can put anything in for x right there. I can put anything in for x and then subtract 25 from it. I don't have any restrictions that I see here. So the way it wants you to write it is what's called interval notation. Okay, up until now, we've said if there were no restrictions, it's been calling it x is a real number. Now it wants you to write it in what's called interval notation. Interval notations are the parentheses and the brackets. The way you say all real numbers, which means I want to include every single number on the number line. What all real numbers means. Any number on the number line. Well, I'm going to have some kind of opening and closing. The way you say all real numbers, what does the number line go to that way? All the way through the negative end of it. It doesn't end, does it? The number line just keeps going. So we call that negative infinity. And then it goes forever positive that way, right? Which would mean it would go to positive infinity. That's how you would say all real numbers, or x is a real number in interval notation form. From negative infinity to positive infinity. Infinities always have parentheses. They don't ever have a bracket. So that's the domain of that one. Now we're going to do it the other way around. We found f of g of x. Now it wants me to find the other one, g of f of x. So this time the inside is f of x. So that's what I'll find first. What is f of x equal? Well, the problem told me what f of x equals. It equals x plus 25. So that's what f of x is, x plus 25. So I'm done with the inside, which means now I will drop down this g. And what do you find g of? Whatever the last part of the answer was. What was the last part of the answer? X plus 25. So what does that mean I need to do? I need to go to my g function now, which is this one right here. And instead of x, I'll replace it with x plus 25. So let's see, instead of x, I'll write x plus 25. And then bring down the minus 25. So just like the last one, what happens with the plus 25 and minus 25? They'll just cancel. So your answer is just that x. So the answer to both of them ended up being the same thing. And the domain of both of them is the same thing, right? Because if I look in these two spots, which is where you would look for any restrictions, I don't see any fractions with x's in my denominator, which means my domain is negative infinity to positive infinity. All right, two more. Number 5, f of x is x plus 4. G of x is 2x squared minus 7x minus 4. So I'm going to do the same thing. I'm going to find f of g of x and its domain, and then the other way around, g of f of x and its domain. So f of g of x first. So my inside is g of x. So that's what I'll do first. Well, the problem was kind enough to tell me exactly what g of x is, right? G of x is 2x squared minus 7x minus 4. So that's what g of x is. 2x squared minus 7x minus 4. That's as far as I can take that part, right? I can't put any of those terms together. So I'm done with the first half. Which means now I'll drop down the f. And what are you finding f of? Your last answer, which is all that. So 2x squared minus 7x minus 4 is what I'm finding f of. Which means go to your f, and anywhere you see the x, which is just right here, instead of writing that x, I'm going to write all of that. So going up, the very first thing right off the bat I see is an x. Well, I don't write it, I replace it with this. 2x squared minus 7x minus 4 is what I replace that x with. Drop down the plus 4. And then see if you can simplify it in any way by combining like terms. Looks like the only things that can combine together are that minus 4 plus 4 at the end. And when I combine them, they just knock each other out, right? So all I'm left with is 2x squared minus 7x. So that's the answer to f of g of x. Its domain. Again, two places you look. The final answer and then the first part answer. Those two places. You can't have any restrictions in any of those two spots. But I don't have any restrictions in either of those spots, right? None of them have an x in the denominator. So there's no restrictions again. So the domain, once again, would be negative infinity to positive infinity. All right, I'm going to find the other way around, which is a little more work. I'm going to find g of f of x. All right, inside first, f of x. Again, this is the easiest part of the problem, right? I need to know what f of x is. Well, the problem told me what f of x was. It's x plus 4. What do you do after the inside? Then you drop down whatever's out here and find g of whatever your last answer was, which was x plus 4. And this is where it quits being so nice. Because what is this telling me I need to do? I need to go to my g function. Here's my g function. What do I put in every spot that I see an x? Instead of x, I'm going to write x plus 4 in both of those spots. So let's see what that looks like. I have 2. Now, instead of this x, I replace it with x plus 4. And then it's squared. Then what's next? Minus 7. What do I put instead of x? X plus 4 again. And then minus 4. Now I do need to simplify that. The first thing I need to do is take care of this exponent. And I'm going to do it over here, because what do I need to figure out? I need to know what x plus 4 squared is. Well, x plus 4 squared, I'm trying to do it like outside of the problem. Means to multiply x plus 4 times itself. So I'm going to FOIL here. Let's see, x times x gives me x squared. Outside, x times 4 gives me positive 4x. My inside, 4 times x gives me another positive 4x. And my last, 4 times 4 gives me plus 16. Put your x's in the middle together, so that turns into x squared plus 8x plus 16. So where do I need to put x squared plus 8x plus 16? That's what x plus 4 squared was. So I have 2 times x squared plus 8x plus 16. I'm just going to drop the rest of this down. Minus 7 times x plus 4 minus 4. Oops, sorry. Then I'll distribute to get rid of the parentheses. So 2 times x squared is 2x squared. 2 times positive 8x is 16x. Plus 2 times 16 is 32. And I'll distribute this negative 7. So negative 7x. Negative 7 times positive 4 is negative 28. And then bring down the minus 4. and then clean it up. And by cleaning it up, I mean combine your like terms. There's no other squared terms besides this front one. So there's nothing to combine with it, so I'll just bring it down. But there are other things I can put together, like this x. Can go with this x, right? Those are like terms. I can put the 16x with the negative 7x, which gives me 9x. And when I put my plain numbers together, what happens to all of them? You've got 32 minus 28 minus 4. So when you put those all together, they just all the way knock out, right? Because 32 minus 28 gives you 4, and then 4 minus 4 is nothing. So you don't have any plain numbers left. So your final answer is 2x squared plus 9x. And then the domain. Let's see. Any restrictions in the final answer? No. Any restrictions in the first part that we plugged in? No. Which means the domain, again, is negative infinity to positive infinity. All right. Last one. All right, f of x is 5 over 1 minus 4x oops, sorry. G of x is 1 over x. So first thing I'm noticing is that I am seeing fractions with x's in my denominators, which means at some point I'm going to have some restriction on some domains here, right? That's what that means. That's what that's telling me. So I am going to be conscious of that. Okay, I'm doing the same things I did to the last two problems. I'm going to find f of g of x in its domain and g of f of x in its domain. So f of g of x first, which means the inside is g of x. So that's what I'll find first. The only good thing about this problem is this right here. I do know what g of x is. 1 over x. Now, oh, my battery's running low. Now is when it stops being nice. Because now what are you finding? You found g of x. You just went up there and looked at it. It was 1 over x. But now I'm finding f of my last answer. What was the last part of your answer? 1 over x. Just follow the pattern. What does the pattern say to do? It says to go to my f function, and wherever I see an x, which is right here, I'm going to put a 1 over x in its spot. And then it gets a little complicated. So let's see, I've got 5 over 1 minus 4. Instead of x, what do I replace it with? 1 over x. All right, I got to simplify this some. Let's see. I need to figure out what is this right here. I'm going to have 1 minus. I've got 4 times 1 over x right there, right? I need to rewrite that in a simpler way. So what does that mean? I've got 4 times 1 over x. Here's the good thing about multiplying fractions. I can think of 4 as 4 over 1. When you multiply fractions, there is no need for a common denominator or anything like that. That's when we get if we're adding and subtracting. Then you got to worry about all that. But when you're multiplying fractions, you simply just multiply the top numbers together and the bottom numbers together. That's all you do. So when I multiply the top numbers together, 4 times 1 gives me 4. 1 times x gives me x. So now I'm just left with 1 minus 4 over x. So let's rewrite what I have. I've got 5 over, when I multiply this right here, it turned into this. Now, here's the thing. MathLab's not going to let you put in that answer because there's too much fraction going on. You got a fraction within a fraction. So I'm going to simplify this. What I want to do is make the denominator of this fraction not have a fraction. The way you're going to do that is whatever you're trying to get rid of, which is that x, right? That's what makes this be a fraction, is that x down there. You're going to multiply the top and the bottom by that. Here's why. So up top is no big deal, right? 5 times x is 5x. But look what it does to the bottom. This x, if I'm multiplying the whole denominator times x, it goes to both of them. So here, the first thing it goes to is this 1. Well, 1 times x is just x. Look what it does here. This is why we used it. What were we trying to get rid of? This x. So it wouldn't be a fraction anymore. Well, this x, if you have an x in the top and an x in the bottom, they just cancel each other. Right? So in other words, this x cancels this one, which means I am just left with what part of this? Minus 4. So that's that final answer, 5x over x minus 4. So remember what we did here, because we're going to do it on the next part too. Whatever you're trying to get rid of, which is the denominator of this fraction, that's what you're going to multiply the top and the bottom by. And why isn't this illegal? Why can't I just multiply the top and the bottom by x? What is, when I put the x over another x, what is anything over itself? Anything. What's a million over a million? 1. X over x is 1. So I am essentially only multiplying this mess right here times 1. Do you change the amount of something when you multiply it times 1? What is negative a billion times 1? It's still negative a billion. You don't change the amount of it when you multiply it by 1. This is just kind of a fancy 1, but it's still 1 because it's x over x. So I'm not changing the amount of it. That's why I can do it. And the reason was I wanted this x to cancel that one so that my denominator is not a fraction anymore. Okay, so that's the answer. 5x over x minus 4 is the answer of f of g of x. Now I've got to find the domain. So let's see, I need to look for restrictions here, which I see. I'm going to have a restriction. And here. In both spots, I have x's in my denominators. So I want to make sure for my domain, I leave out any numbers that make this or this 0. Right? You can't have zeros in your denominators. So in both of those spots, whatever your denominator is, you need to say that can't equal 0. Well, this one was just x. So when I said it couldn't equal 0, I was done with that, right? There was nothing to solve. What about here? x minus 4 can't equal 0 either. I do need to work a little bit to solve that, to see what x can't equal, but it's not bad. I just need to get rid of that minus 4 with a plus 4. So what else can't x equal? It can't equal 4. So there's 2 restrictions in the domain. X cannot equal 0 and x cannot equal 4, which means it can be anything else. Now, this part at least is multiple choice, so you're not going to have to type in this whole interval notation because it's a little bit complicated. I want to say x can be all the numbers from negative infinity to positive infinity except 0 or 4. So the way that you write that, actually I'll do it over here. So the numbers start at negative infinity. So that's where I'm going to start. Now, I want to end at positive infinity, but I want to leave out 0 and 4. So the first thing I'm going to leave out is the 0, because if I'm starting at negative infinity, the first number that I'm going to come up to on the number line is that 0. So that's how I want to write it, negative infinity to 0. That means all the numbers below 0 are fine. Since I put a parenthesis around that 0, that means I don't include 0. That's what's leaving it out. Then after that, there's a little u, and it means in union with. And again, it's multiple choice, so you're not going to have to find this stuff. This part is multiple choice. It means and. So all the numbers below 0. And now I want to say all the numbers between 0 and 4, right? Because those are fine. Everything between 0 and 4. So the next parenthesis is 0 to 4. Again, the 0 and the 4 have parentheses around them, which means those particular numbers are excluded. And so all the numbers below 0, all the numbers between 0 and 4, what's the last group of numbers I want to include? All the numbers above 4. So where would I start? I would start at 4 and then everything above it, which is infinity. So that would be your domain. There's the first half of that problem. So what did I find? I found f of g of x, which gave me 5x over x minus 4. And then I found its domain, which means I needed to leave out 0 and 4 because it made zeros in my denominator in those 2 spots. So now we're just going to flip-flop it. We're going to find g of f of x and its domain. All right, following the pattern. The first thing is f of x. Again, the only good part about this problem is I know what f of x is, right? The problem tells me what f of x is. It's 5 over 1 minus 4x. So I'm done with that part. I drop down my g, and here's complicated, right? Because what am I finding? G of my last answer. What is my last answer? 5 over 1 minus 4x. Okay. My steps tell me now that I'm going to go to my g function, and I'm going to replace this x. Oops. And I go to my g function and replace this x with 5 over 1 minus 4x. So just go with the flow. I have 1 over, what do I put instead of x? This. Yeah, good. 5 over 1 minus 4x. Now, remember, Math Lab's not going to let you type that answer in like that because your denominator of your whole fraction has a fraction. So remember what we did on the last problem. The denominator of that bottom part of the fraction of the first part of this problem was an x. So that's what we used in the top and the bottom, right? Because that's what we wanted to cancel was the x. This time, what's the bottom? What's the denominator? 1 minus 4x. That's what I'm going to use. If that's what I'm trying to cancel, that's what I need to multiply by. And I have to do it on top and bottom, right? Because what am I actually multiplying all this mess by? 1, right? It's the same thing on top and bottom, so I'm only multiplying it by 1. It's just a fancy 1. So let's see. This is actually not as bad as the last one. 1 times 1 minus 4x is just 1 minus 4x. What happens in the bottom? This 1 minus 4x cancels that one. So all you're left with is 5. So that's the answer to g of f of x. Now let's find the domain, which means I'm looking for restrictions in 2 spots. My final answer, and then what I plugged in. The good thing about my final answer is it is a fraction, but what's not down here? There's no x in my denominator, which means this part doesn't have any restrictions, right? Doesn't matter what I plug in for x, the denominator of this is always going to be a 5. So there's no restrictions in the final part of the answer, but what about this part? Yeah, this one does have a restriction. So I need to make sure that 1 minus 4x can't equal 0. Solve it for x. So subtract the 1 off both sides. So negative 4x can't equal 0 minus 1 is negative 1. Divide both sides by negative 4. So now I see x cannot equal, that negative over a negative turns it to positive 1/4. So it just can't equal 1/4. It can be anything else though. So how would I write that? All the numbers on the number line from negative infinity to positive infinity except 1/4. Which would be negative infinity to 1/4. That's all the numbers below 1/4. And then all the numbers above 1/4. So, and 1/4 to positive infinity. Okay. That is it. I've got online, I've got everybody's name in here, right? Yeah, I did. So I've got Maggie Davis, Devin Marshall, Bailey Ledoux, Tabitha McCauley, Altenegro, I know I'm totally butchering your name, Carmen Polk. Okay, I think I got everybody. I will see y'all on Wednesday, and we will do 9.2 on Wednesday.